Okay, so I'm going to go here, and now I'm going to go here. All right, so welcome, welcome, welcome. What we're going to do is we are going to talk about the abacus. We always talk about the abacus. Is there anything else that you talk about? No, this is all I talk about. Okay, so what we're going to do is read the abacus. What we're going to do is we do 1, 2, 3, 4. Okay, and so then after 4 we have 5. Well, what's after 5? 5 is always going to be the top beat. 5 will always be the top beat. So because 5 is the top beat, now we can count to 6. So notice if I have 1 and I add the 5, now I have 6. If I have 2, right, I have 2, and then I add 5, now I have 7. And then if I have 3, that looks like it's 3. Now if I add the 5, it is 8. And now if I have 4 and I add the 5, now we have 9. So what we're doing is we're reading the abacus and we're going to understand how to read it, and then after that we can do some adding, subtraction, multiplication, division. I hope we can get to division. Okay, so the first thing we're going to do is we're going to learn to read the abacus. When we learn to read the abacus, we're going to do 1, 2, 3, 4, and then 5. After 5, we have 6, 7, 8, 9. And then after 9, what do we have? 9. Ooh, that's not right. No, discard. Ooh, sorry. So what are we going to do? After 9, we have 10. So this is 10. Notice that this and this is kind of similar. So we have this and this. So what's going to happen is 10 is here. And then we do 11, 12, 13, 14. Now notice we have 14. Thank you so much for the likes. Hello, Ethan. Welcome back. And so what we're going to do is we're going to... hold on, please, abacus. Okay, and so what we're going to do is after that, we need to understand that this is 15, so 1 and 5, and then this is 25. How do I know this? This is crazy. Well, what's going to happen is if you notice, this is all about place value. So the abacus mimics the way we have our place value. This is our place value. So we have our 1s, our 10s, our 100s, our 1000s, and our 10,000s. And I need to edit this, and I need to remove it. And then I need to add it again. Oh, sorry. Pause. So I need to, there. So what we're going to do is we're going to count 1, 2, 3, 4. And then after 4, we have 5. After 5, we have 6, 7, 8, 9, and then 10. 10, 11, 12, 13, and 14. So notice we have 15. When we have 1 and then we add the 5, now we have 6. Let's see. Okay, so we have 2 and we add the 5. Now we have 7. We have 3 and we add the 5. Now we have 8. We have 4 and then add the 5. Now we have 9. Does anybody have any questions? Let me know. What we're doing is we're going to learn how to read the abacus. After we learn how to read the abacus, then we can add, subtract, multiply, and divide. But then it all depends on how far we get. Not sure if we're going to be able to get to. So what's going to happen is we're going to count. We have 1, right? This is not 1. This is 10. How do I know this is 10? 10 because we have our 10s. So if this is not 1. This is 100. And then what do we have after that? We have 1,000. And then after that, we have 10,000. Does that make sense? Let me know if you have any comments or questions. Please let me know if you have any questions. So what we're going to do is, again, we're going to read the abacus. When we read it, we go 9. So this 9, 9, 9, 9. All of these are 9, and that's 9, 9, 9. So that actually looks like this on the abacus. So remember, this is our place values. So we have 9, 9, comma, 9, 9, 9, period, 9, 9, or decimal. And so that's what that looks like. So we have 9, 9, 9, 9, 9. And then, so one of the questions could be, why am I starting here? Well, the reason why I start from in the middle, kind of in the middle, the third column out, the reason why I start over here is because I have my dot indicator, my ones indicator. Because I have my ones indicator, that is where I'm going to start my counting. So when I count, I could do 1, 2, 3, 4 because I have my indicator. Because I have my indicator, I have 5. And then after 5, I have 6, 7, 8, 9, and then what's 10? That is 10. How do I know? Because 10 looks very similar to 1. It's just a different column. It's just a different column. So we have 1 and then 10. And then we have 100 and we have 1,000. And then after 1,000, we have 10,000. My abacus came. Yay! Welcome. That's fantastic, Jake. I'm so happy. Okay, so then that means you can start counting with me. So we can count 1, 2, 3, 4, and then 5. After 5, we have 6, 7, 8, 9, and after 9, we have 10. After 10 is 11, 12, and then look, if I have 12 and I add the 5, now I have 17. And then if I have 13, I add the 5, now I have 18. And then if I have 14 and I add the 5, now I have 19. Let me know if you have any questions. But that is fantastic, Jake. I haven't seen you in a while. So it could also be interesting. So anybody have any questions? Do we know how to read the abacus? If so, let's do a little game, shall we? Here is a maze that I've created. And what we could do, what about the right two columns? Oh, thank you, Loopy. Yes, the right two columns. Wait, can you slow down? I'm processing. Bella la la la. So the tens only goes up to 50? No, it goes up to 60. So the other two columns here is the decimals. So just like how we have our ones, our tenths, and our hundredths. So now we can do decimals. And when the question was to go up to 50, if I had 50, that's 50. Now what's after 50? This is 60, 70, 80, 90. And what I'm doing is I'm counting from here. So all the bottom beads has a value of 1. So we have 1, 2, 3, 4. And then I was just reiterating that this is 5. So after 5, right, we have 6. But then notice the 1 looks this is 1. But when we add the 5, now we have 6. I know how to use the abacus. I've been here for 30 seconds, right? It's easy, simple to use, easy to understand. And so then when I look at it, this is 20. And then I add the 5. Now I have 70. When I do 30, right? 1, 2, 3, I add the 5. Now I have 80. And then when I look at 40, 1, 2, 3, 4, and now I have 90 because I added the 5. The 5, this top bead will always be 5, no matter what. So what we're doing is we're understanding how to read the abacus. When we understand how to read the abacus, we can go further. So, Samara, did that make sense with the tens and counting up to 50? So we can count more than 50 because we have more columns. We have our ones, our tens, our hundreds, our thousands, and our 10,000. Okay, great. Let me know if you have any more questions. Loopy, let me know if you have any questions. And Bella la 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 la. Does that make sense? Dean over Dina. Wait, can you explain it again? Yeah, let's go. Oh, I get it now. Okay, good. Bella la 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 la. So we're going to review counting. What we're going to do is we're going to review counting. What does that mean? Well, every bottom bead, all the lower beads has a value of 1. So when we count, we have 1, 2, 3, 4. Now, I am over here. This is my ones place. And then we have 5. Notice when I have 1 and I add the 5, now I have 6. When I have 2 and I add the 5, now I have 7. When I have 3 and I add the 5, now I have 8. When I have 4, 1, 2, 3, 4, and I add the 5, now I have 9. So what 9 looks like is this. That's what 9 looks like. 8 looks like this. And then notice what I do is I move the beads all at the same time. Dean, did that make sense? So when we're looking at it, this is my ones. Here is my tens. So I could do 10, 20, 30, 40, 50, 60, 60, 70, 80, 90, and then 100. And notice that they're all place values. So the abacus really mimics the way we write. When we write, let's say 220, 2025, right? 2025, like the year 2025, 2025. And so that's what it looks like. 2025. Yeah? Oh yeah, right? Easy. Easy to, simple to use, easy to understand. So that's what this is. This is available on my website, links in the bio, if you want a chart. So what this is just a chart on how to read the abacus. And we're just going to go through 0. It looks like this. Notice that none of the beads are touching this horizontal bar. This horizontal bar is what tracks our numbers. Oh my God, it came, guys, it came so fast. Ah, thank you, Jake. So what's going to happen is, if you notice that this is the horizontal bar, this horizontal bar is what tracks our numbers. That's all the abacus does. It only tracks our number. And what we're doing is we're learning to read the numbers. When we learn to read the numbers, we're going to read 1, 2, 3, 4. Notice I'm at the ones place. The reason why I'm at the ones place is because I have this indicator. This indicator is my ones place. So I have my ones, and then my tens, my thousands, my hundreds and my thousands. So I can count. Any one of these can be 9. So all of these together is 99,999.99. Does that make sense? Let me know if anybody has any questions. What kind of questions do we have? So the first thing we're going to do now, actually the next thing we're going to do, is understand how to read, how to go through a maze. Let's go through a maze. This will be nice because this is a maze that I made. I made a maze, and so it'd be easy to understand how we're going to read it. Yeah, thank you for the follow. So what we're going to do is we're going to start here, and I'm going to cover it up so nobody can cheat. So the question is what number do we think this is? If I look like that, what number do you think? Of course an Asian knows and make mazes. Josh. Of course. And you know what? I love puzzles. I have so many puzzles. And you know what? My stuff is entertaining and interesting. Thank you, Josh. Of course. You know, I was thinking that the same thing. It's like, of course an Asian's teaching abacus. Like, who would have thunk it? 61. Yes, Linux. 61. How do I know? Because it's 1, 6, and then 1. I don't know what that is. FR it is. I don't know acronyms. Yes, 61. So what we're going to do is, now we know how to read the abacus. How do we do math with it? What's the purpose of an abacus? The purpose of an abacus is to help you add, subtract. Oh, for real. The purpose of the abacus is to help you add, subtract, multiply, and divide. So so that means that we don't want to go through the maze, because if we don't go through the maze, then I'm going to start going through some arithmetic. Thank you so much. I appreciate the translation, because I'm old and I don't understand acronyms. Because the only acronym we used to do when I was a kid was like ASAP. Okay. So anyways, best math lesson for. Okay, that means that you guys don't want to do the maze. Is that what I'm hearing? Because then we can go straight into adding and subtracting. Oh, I'd like to see the maze. Oh, you would like to see the maze. Is the next one? Oh no, wait. Oh, you're jumping ahead. Okay. We'll do the maze. We're going to do the maze because I want to make sure everybody understands. So, yes, the next one is 39, because 1, 2, 3, and then 5, 6, 7, 8, 9. You guys are so good. All right, so that's 39. And then what's the next one? That one is what? Maze me. Okay, good. I'm so happy, because after the maze, then we can start doing adding and subtracting. So this number and then that number. What number? Hey, Ned. Yes, thank you. So we do 5 and then 7. And so then we do we got to color that in, and then we're over here. Now we have this one. And what we're doing is we're just practicing how to read the numbers. Oops. Oh, so yeah, we're just practicing I'm still confused. I should have got here earlier. Not a problem, Josh, not a problem, because what we're going to do is we're reading the numbers. So if you look, it is 64. Yes, Bella. So if you look, we have 6 and a 5 and a 6, and then 4. 1, 2, 3, 4. Every column is a place value. So this is 64. Where's 64? We're going to go here. So because we're going through the maze, it'll be easy to do. So we have this number. If we look, the ones, the ones is over here. So we have our ones, our tens, our hundreds, right? Our ones. We have 1, 2, 3. Thank you. Yeah, that's easy, right? Because you guys are good. So that's the 3, and we go down here. So now when we look at it, Josh, I hope you're still here. We're going to look 5. So we have 1, 2, 3, 4, and then this is 5. After 5, we have 6, 7, 8, 9. Hello, Luca. Welcome back. Yes. Yes, Bella, it is 99. Josh, does that make sense? Josh? Yeah, Josh, does that make sense? So now we have 9. And then, Bill, welcome back. How's the job? Okay, so yes, 99. How do I know? 5, 6, 7, 8, 9. And then, I feel bad for being mean. Now this shit's fun. You were being mean? That wasn't being mean. That was just being obvious. Stressful. It is stressful. The new job is stressful. I thought Josh was just being obvious. 5, 6, 7, 8, 9. Yeah, the colors help. Yep, the colors help. Is the 12-inch ruler taller than a... I don't know. This is so simple. It is simple for right now. But when we start going into equations, then it will be a little bit. So the first thing we're going to do is understand this. So we have that number and then this number. What number is this? It will be easy. I will guide you through just as I'm guiding you through this. 91. Yes, thank you, Dean. Thank you, Bella. 5, 6, 7, 8, 9, and then this is 1. What? That thing was, yes, you're absolutely right, Josh. This was in the Tinkerbell movie. This is also, and have you ever seen Wonka? Wonka, there was an actual character name. His name is Abacus Crunch. Yep. You know, Josh, I'm just saying, I don't think you were being mean. I think you were just being obvious. You were being mean. You would have told me that I'm a horrible, horrible, bad person, and I'm not a good teacher. That would have been mean. That would have been very hurtful. And I've had a few people that came in that. Yes. Thank you, Ned. Thank you, Bella. Thank you, Dean. We have 7, 5, 6, 7, and 5, right? So that is 75. That is how we get 75. Yep. Anybody had what is it? What do you call it? Sesame Street. And they had these aliens, and they would go yep. Okay. Anyways, what are we doing? What number is that? I love that little skit. They started talking about the telephone. Yes, 54. Yes, 5, and then 1, 2, 3, 4. Yes, exactly. So we're going to color that in. We're almost done. That's how old I am. When that one Sesame skit, when they were talking about the aliens, they were coming down. Yeah. Anyways, Move Phone. I don't know Move Phone. Josh, no. 1, 2. That's 2, right? And then this is 5. Yeah. So it's 25. Oh my God. I love how easy I'm finally getting it. And I used to think this was so complicated. It is not complicated. Bill, I can't believe you know that one. That's like crazy. That was like crazy. That's really crazy. I still watch it sometimes because I like that stupid skit. Okay, so our final, almost done. We have 1 here, and then we have 1, 2, 3. No, that's not right. 5, 6, 7, 8. There we go. Right? Okay, good. 8, actually. 8. Because it's 5, 6, 7, 8. Yeah? Got it? We're okay? Yeah, right. I love it. All right. Okay. Oh my God. So I was judging track field, and their kids are young, right? The kids are like 16, 17, 15, 16, 17. Like I'm at a track field, and I was judging jumps. They were doing jumps. Rotary phone. Yeah. So I was doing the jumps, and I said something like, people were like do I need to put my name down? I was like, yeah, put your name down. And the way, and I'm like, yeah, we're all going to just, get to know everybody, and we're all going to sing Kumbaya. And they're like, what's Kumbaya? And I'm like, my God, you don't know what Kumbaya is? I thought that was like anyways. So they didn't know what Kumbaya was. And I was kind of like, wow, I'm really old and I need to stop that joke. I need to stop that joke. Yes, this is 42, right? 42. It is the answer. Hello, keeper. Oh my God. Hi. I can't stay because it's almost one. Oh my God. I can't believe you're here. Nah, these new gens. How do people, right? We all hold hands and we all sing Kumbaya. So this is my maze. Thank you everybody for participating. Thank you, Keeper, for coming by and saying hello. Yes, yes, go to bed, go to bed. I was actually kind of contemplating whether I should come on or not, but I needed Josh to tell me. I needed to meet Josh and Bella and Ned and Ellie and Dean and Cooper's mom and who else? Who else? I did that. I did. Yeah. Okay. What's next? Okay, what's going to happen next is we're going to start understanding how to read the abacus. We already did that. What we're going to do is we're going to add now. Now, why are we going to do this? We're going to add, and how does it work? Because we want to understand how to move the beads. When we move the beads, whoa. Oh my gosh. Do you make YouTube videos? Yes, it's in my bio. This is why I'm on the internet, right? I love the internet. Wait, I'm so slow. Why are you slow? You're not slow, Bella. You got it. Okay, so, oh my God, finally, yes. So, I'm 19, I only know Kumbaya from Alvin and the Chipmunks, right? Hello, Labrador Moose. Okay, so what's going to happen is we're going to understand how to move the beads. What does that mean? Well, when we look at the abacus, at school we're teaching the kids how to add, but the problem is we don't teach them what the answer is. What we teach them, we focus on, is the add-in. This is what we call the add-in. The add-in is the number that we're adding. So what happens is when I have 5 and I want to add the 1, this is 1, I just want to add the 1 bead. That's all I'm doing. Have a good night, Keeper. Yeah, I'll see you next time. I'm going to try more regular, but I'm still trying to figure out my schedule because it's still tough to have kids and stuff. So, and my schedule's still off, but I'm trying to figure out how to get a better schedule. So, if you notice, what we're doing is we're checking to see if we have enough beads. Good night, Josh. So what we're just going to look at the beads. So this is 7. I want to add the 1. When I add the 1, all I got to do is move the 1 bead. Oh my goodness. It's not difficult. It's not difficult. So notice I only add the 1 bead because it's a 1-to-1 down here. The only difference is this is not a 1-to-1. This is a 5, right? So all the top bead has a value of 5. So when I add the 1, now we have 6. So when we look at it, we want to do the adding of the 2. When we add the 2, it's the same thing. I want to add the 5, and we've seen this before because that's how we make 7. We have 5 and we have the 2. Bring it together and there is 7. You guys lock in. Once you find out, it becomes easy. Yeah, trippy. Okay, Bill, have a good night. Yeah, good luck on the test. Is the finger thing in math the contest when the numbers flash? Yes. So when they're doing this, right, that's kind of dramatic. They're actually doing this. And really what it is they're moving the beads in kind of muscle memory. And so they kind of imagine the beads in their mind's eye, if that makes sense. So when we go through it, that's why if you notice my fingers that I'm using is the index finger to move the top bead and the thumb and to move it to the horizontal bar or away from the horizontal bar. So when we notice is when I go to the horizontal bar, I am adding. I have state testing pretty soon, so I'm trying to learn. Oh, Bella, I don't think you... Good luck. So what we're going to do is when we add 6, notice, hey, Amma, welcome back. Thank you, Bill, for the heart me. Thank you, Amma, for the heart me. So what we do is when we add the 6, don't forget what we're doing is we're going to the horizontal bar. When we want to go away, we want to take away, we want to minus, we want to take it away from the horizontal bar. So what we're doing is we're adding and we're subtracting. I'm an engineer degree, y'all, and I'm still learning. That's funny, Bean. So when we add, we want to go to the horizontal bar. When we subtract, we go away from the horizontal bar. So if you notice, I'm just going through, we're adding and subtracting. So here, I'm adding 5. I want to go to the horizontal bar. Now I want to add 3, and I want to go to the horizontal bar. When I subtract, I want to say minus 6. I'm going to take away. So it's minus 6 and I move it away from the horizontal bar. I hope that makes sense. So when we go in, we go to the horizontal bar and away. So this is why the horizontal bar is key. This is what tracks our number. Now notice we are focusing on the add-in, right? We're not focusing on the result. Oh, see, I told you, Bella, you're not slow. You're not slow. Okay, so what we're going to do is we're going to add the 5. We're going to add the 5. When we add the 5, I want to add the 4. When I add the 4, I'm moving it to the horizontal bar. When I want to subtract the 4, I want to take it away. Does that make sense? So what's going to happen is now I'm like learning how to move the beads. I'm adding to and I'm subtracting away. Adding to the beam or subtracting away from the beam. Yeah. And again, it's the same thing. We already did the minus and now we're going to do it again. So if I have 2 and I take away 1, that's what I do. I'm only going to take away the 1 bead. It doesn't matter which bead I take away. So if I have 3 and I take away the 1 bead, that's all I'm going to do. I'm only going to take away this 1 bead. All I'm going to do is take away a bead and a bead, a bead, a bead. Okay, so we have 2, right? Here is 3. This is my question is 3. When I add the 3, I'm going to take away 2. When I take away the 2, it's these 2 beads. It doesn't matter which 2. Just take away any 2 beads. Can we try an example like 6 plus 9 or something? We can, actually. But it's going to get better because that's a little bit further ahead. So let me finish my thought on the simple. This is what we call simple. Now, why is it simple? Because we don't need any formulas. This is a lot of the question is can we do it? Yes, we can. Who knows Bob the Builder? I cracked myself up. Okay, so we have 3, and notice when we add the 3, and my question is 5, and my of course you do because you're the engineer. So we want to add the 5. The question is, can we add the 5? Yes, we can. So that's why this is like the Bob the Builder area, right? Why? Because we want to be able to add the 5, and it's again for the 6 and the 7, right? So if I have 1 and I want to add 7, I'm adding these 2 beads. 5, 6, 7. I'm going to add these 2 beads. Yeah? Can we do it? Yeah. Bob the Builder, can we do it? Yes, we can. Okay, so we're finally going on to the 8, right? 8 doesn't have a lot of questions because it's only 1 and then 8. 5, 6, 7, 8, and that's it. Well, what is the biggest question now? The biggest question is we're done. No, there's more to it. Obviously, there's a minus, but we've already know how to minus, okay? And it goes only to 9. So this is what we call simple adding. The reason why is because we have no formulas. What does that mean? Well, what it means is if I was to add a number like, here we go. If I want to add a number, we're teaching the children. We're teaching the children these things. This is actually a very crucial concept. This is a crucial concept. We're teaching children how to make a 5. The reason why we make a 5, I don't know why we're teaching children how to make a 5, but I know why we do it in the abacus world. But this is a very common thing in the mainstream math to teach the children how to make a 5. I don't know if you guys were ever taught to learn how to make a 5, but this is what they're teaching the kids. Now, the reason why this is very interesting, in mainstream math, they don't do, that's it. That's all they tell you. This is how you make a 5, and that's it. And then you just kind of walk away, and you kind of like, I don't know what else to do with it. But in Abacus, we actually take it one step further. We actually level it up. Why? Well, when we get to the point to like add the 3, so I'm going to add the 3. My question is plus the 3. Notice I want to add 4. I cannot add the 4. Wait a minute. I have something that can help us. This thing over here is plus the 4 is equal to 5. Plus 4 plus 1 is equal to 5. That's not going to help us. No, it's not. What we're going to do is now we're going to isolate this variable and we're going to make it work for us. We're going to make our freeloading numbers work for us. So we have 4 is equal to 5. Notice that this is not balanced. If this is not balanced, what are we going to do? We have to minus the 1. So what we need to do is we need to isolate the variable. That's what this is. We're going to isolate the variable. The 4 and this 4 is the same. So what we're going to do is we're going to substitute this information into this 4 over here. Does that make sense? So what's going to happen is I have, and this is giving you directions, so there's no beating around the bush. What's going to happen is when I add the 5 minus the 1, and my final answer is 7. We in Abacus World do not memorize our in the Abacus world, you're losing me. In the Abacus world, we do not memorize doubles. What we memorize is our formulas. This is a formula. So what's going to happen is, okay, no, that's good. Thank you for letting me know. What's going to happen is we're going to do it again. And we're going to understand when we look at it, we got to figure out how to use this bead. This is why we have this, is to understand how to use this top bead. So if I have 3, if I have 2, let's do 2. If I have 2, I want to add 4. My question is 2 plus 4. I don't have any more beads to add the 4. But what do I have? I have to look at my resources. One of my resources is, I get it. You just expanded my brain. Yeah, exactly, Ellie. We have to use the 5. The 5 is our resource. But if you look, if I add the 5, if I do 4 is equal to 5, is that balanced? So you have to take away, yes, to balance it, right? Here. Maybe this will help. So I have 2. I want to add 4. Right? I want to add 4 to this, but I only have a nickel. What do I do? Well, let's do an exchange. I'm going to give you the nickel, but I need to take back the penny. So my final answer is 6. Does that make sense? Ah, yes. See, it's different. Why? Because we need to understand that this is a 5, right? This is a 5. This is the nickel. So this nickel is worth 5 cents. So if I have 3, but I only have 5 cents, what am I going to do? I'm going to give you 5 cents, but I don't have 4 cents, right? So what's going to happen is I'm going to give you my 5 cents and I take away 1 cent. That just clicked, right? Yeah. I thought that was brilliant. When I figured out this with the money, I was like, this is perfect. So it's the same thing. If I have 3 pennies, right, and I want to add 4, I don't have enough. I have 5 cents. I will give you my 5 cents, but I need to take away the 1. So my final answer is 7. What's next? Well, see, that's why we do this. That's why we have to understand this. As we understand this, we could do the same thing with the 3. So let's say we have 4. We have 4, right? And I want to add 3, but I only have 5 cents. So what's going to happen? I have to take away the 2. So I give you my 5 cents and I do an exchange and I take away 2 pennies. So my final answer is 7. Wow. Whew. Does that make sense? So I think this helps with the whole money thing because it makes sense, right? Okay, good. So that's the thing. We don't need to memorize doubles because doubles is very specific and is not very versatile. But this formula is what I just showed you. This formula is very versatile. So that's why we learn our formulas before we learn our anything else. Okay. So like here, if I want to add 2, to 4, right? I don't have more beads. So if you look, I have 4 and I want to add 2. This is my, right here. 1, 2, 3, 4. 1, 2, 3, 4. I need to add 2 to this. If I need to add 2, I only have a nickel. What do I do? If I only have a nickel, I'm going to exchange it. I'm going to give you my nickel. How many do I get back? Right? The 2 and the 3 are pairs. So what's going to happen is I take away 3. So my final answer is 6. So it's like add the 5 and take away the 3. Exactly. Exactly, Ellie. Thank you. That's how it is. And what we're doing is we're moving the beads so we can see what the numbers are. Does that make sense? Great. Yeah, I'm back. My girlfriend woke me up. Now I need math lesson to wake up. Okay. So now we've done that. So what we can do is we can do more, right? We can do a little more to practice. And this is about focusing on the formulas. So in Abacus world, we call it formulas, right? You missed the good part, Josh. I'm not going back. I'm not going back. I'm not going back. Okay. So what's going to happen? Now, what's going to happen is, let's do another one, right? And it's the same thing. Again, we don't need to know, we don't memorize our doubles. What we're going to do is we're going to understand how to utilize our formula. So, oh, that's the wrong formula. So the formula that we have is plus the 4 is equal to plus the 5 minus the 1. Right? So when we do that, plus the 4 is equal to plus the 5 minus the 1. And when we look, we don't memorize the formulas. What we do, we don't memorize the doubles. We memorize our formulas. So we have the 4, and I want to add 4. To add the 4, I want to add the 5, and I want to take away the 1. Notice their directions, right? I'm not beating around the bush. Just do exactly what I tell you, and you'll be fine. So I want to add, if I want to plus the 4, all I have to do is plus the 5 minus the 1. And their directions are right there. So we can do it again for the 3. When we do the 3, let's do 6. Let's do 3 plus 3. 3 plus 3. Oh, I can't do it. Well, what's the formula, right? To know the formula is 3 plus 2 is equal to 5. When we do this, what's going to happen? Plus the 3 is equal to plus the 5, but that's not balanced. So it's been formulas this whole time. Yes. This is the formulas that we are talking about. There's 2 sets of formulas, and then you will know everything. Let me just continue on, right? So I know that everybody always wants to go to multiplication because that's the quick. I don't know why. I don't know why. There's more. I think adding is really underrated, but we don't go like in Abacus world. We like add 10 and I don't know. I don't know how to do new math. I just know how to do Abacus math. So here we want to balance. To balance it, I want to minus the 2. When I minus 2, yes, thank you guys. Oh yeah, see? Makes sense, right? So I'm going to add the 5 and I got to take away the 2. So my final, oh, that's not right. Oh no, 6. Yeah, so it's 3 and then take away 2. Yep, so then the answer is 6. So sometimes it's hard to read my beads because I move my abacus too much. And when I move my abacus too much, my answers get messed up. So exactly what that is. Dean and Ellie, makes sense, right? So a lot of these is about the formula. Well, what happens now? Here, let me give you another thing, okay? What we're doing is I'm pushing you guys over the edge. Girl, I feel like I paid this for knowledge. I feel like I have to pay for this knowledge. What was I going to say? Oh, here. I'm taking notes for my kids. Yeah. I have workbooks. I have workbooks, and I'm going to flood the market with all of my Abacus worksheets. I got more worksheets. It feels like school when we had Corona. Yeah. Yeah. Good morning, good evening, good morning, Audrey. Good morning, Audrey. All right. So, okay, we understand that there's this. We understand how to make a 5. I'm done. We're so done. Done. That's it. Anything else? This is boring now. No, no, no. There's more. But wait. There's more. Now, we are going to be learning how to make a 10. What? Yes. Once you know how to make a 10, then you know how to subtract and add all and everything that you want to know. It's so cool. It's really quite cool. Okay, so what are we going to do? Well, now, when do we do it? Well, we do it when we need to. Why? Because if I had this one, I have 4. I have 4, and I add the 9. I don't have enough beads to add the 9. But wait! I can. See, now we know, right? We have a process, we have a pattern. Look, this is very familiar, isn't it? But different numbers is equal to 10. What am I going to do? I'm going to isolate this variable right here. What happens? This is going to move over here. 9 is equal to 10. This is too big, minus the 1. So what's going to happen is 10 is 0 and 1. That's what 10 is. 0, 1, 10, 1, 0. I'm going to add the 10. I'm going to add the 1. And yeah. Final answer is 13. Hopefully we're all back online because it's starting to get exciting. So what's going to happen? Let's do it again. Let's do it again because I don't know what's going on. So I want to add the 3. When I add the 3, I want to add the 9. I need to add the 9. We know that there's a pattern, right? Just like as we did the 5. Just like we did the 5. Now we know we have a pattern. So if I want to add the 10, if I want to add the 9, how do I do it? Adding the 10, adding this 1 here, 0, 1. If I add this, this is too much. So what do? I have to subtract the 1. Now we're balanced. It's just like the yin and the yang. Like the, what do you call it? The balancing balance, whatever it's called. I don't know. So, does that make sense? When we go to 2, we're going to add 2. And then I want to add the 9. I plus the 10 and take away the 1. Yep. Yeah. So then my answer is 11. So, is this a roundabout way? This is very visual. As opposed to when you learned in school, they were taught you had to memorize. You had to memorize that 2 plus 9 is 11. You had to memorize that. And you had to focus on you focus on the 11, which is the result. But in Abacus, you focus on the add-in. This add-in is what makes and breaks it. It's all about the journey. So now we're talking about Abacus and life. Abacus follows the journey of life. I'm a visual learner, so this helps. Oh yeah, Dean. Nah, we had to show our work if we memorized, if we could, still got, yeah, yes, you showed your work. However, it's still a picture as opposed to on the abacus. So I only know how to do new math in multiplication, but we can talk about that later. But when we talk about this is not really showing, this is kind of showing your work, but I'm only showing it because I need to show you guys. But really, when I look at it, I already know how to do it. So if I add the 1 and I want to add the 9, I know I'm going to do this plus the 10. So that's what that is. And then it goes through, right? We have more. No, now what's going to happen is, wait, what about the minus? Well, we know the minus, right? The minus is what? When we look at it, we do minus 9 minus 1 is equal to minus the 10. That's what we're going to do. And look, it's still very familiar, right? It's minus the 9 is equal to minus the 10 plus the 1. So when we have 18, and I want to take away 9. When I take away 9, I need to minus the 10 and plus the 1. So my final answer is 9. So we know how to add, we know how to subtract, right? It goes balanced. You have a left, you have a right, unless you're an amputee. Okay, but jokes aside, you have your one side, you have your other side. You have a positive and then you have a negative. So when you look at it, right, we're compounding the math knowledge. So we're understanding and we're compounding the math knowledge, and we're just building into it, and we're practicing. As we practice, people will get used to it. When you get used to it, thank you so much for the hearts. When you get used to it, right, it makes more sense. I mean, I've been teaching abacus for about 20 plus years now, so sometimes I forget to explain what my thinkings are. Yeah, I'm old. Anyways, so now what's the secret? This is the secret. What does that mean? We know how to add a 5. We know how to subtract the 5. We know how to add the 10. We know how to subtract the 10. Now you have everything you know to, oh, have a good night, Linux. Now you have everything you need to add and subtract any number, no matter how big. Because now what we do is we're going to be able to Tetris our way and build on top of it. What does that mean? Well, let's do this thing called a two-step equation. Now we're going into a little bit more algebra, because in algebra we talk about two-step equations. The first thing we're going to do is understand when we... That's not what we're going to do. Here. There we go. We're going to look at 8 plus 5. Maybe I should rewrite it. I'm going to rewrite it. We're going to do 8 plus 5 and 5 plus 8. We're going to do 8 plus 5. Nah, I hate algebra. My worst nightmare. I'm a calculus gal. But we have been doing algebra. I'm not sure if you knew that. I'm telling you. I'm telling you. You want to see the algebra? We did algebra. We did this. 9 plus 1 equals to 10. It's the same thing as x plus 1 equals to 10. Right? Wait, I've been teaching you algebra. But not really. I'm not algebra. I'm abacus. So what did we do? We isolated the variable. We went from here and we take this and we move it over here. So we did this. X is equal to 10 minus 1. I'm going to rewrite the formula. I'm going to substitute it in. I'm going to do 9 is equal to plus the 10 minus the 1. Then what happens? We take this information and we substitute it into our question. We just did 9 plus 9. What did we do? We took this information, we substituted it into here. Isn't that what algebra is? But that's as far as algebra I go. I don't know anything else. That's above my pay grade. All right. Okay, that's enough. Now, what we're going to do is we're going to do some more adding and subtracting. This specifically is what we call two-step equation. With a two-step equation is interesting because there was this one parent I had, and she was like, I want my child, and isn't like 8 plus 5 and 5 plus 8 the same? And I'm like, no. Why? Because we're talking about the add-ins. The add-ins is what makes the difference. It's about the journey, not about the destination. So when we look, we have the 8 and I want to plus the 5. When I plus the 5, we know how to add the 5. How do we add the 5? We have to add the 5. Plus the 5 is equal to plus the 10 minus 5, right? So I'm going to plus the 10, take away the 5. My final answer is 13. Great. What's next? Okay, let's do the other one, right? 5 plus 8. When we do 5 plus 8, we do the 5 and we do the 8. There's not enough beats to plus the 8. Now what are we going to do? Well, plus the 8 is equal to plus the 10 minus the 2. Okay, plus the 10. Minus the 2. Ruh-roh. Cannot minus the 2. What are we doing? What are we doing? Ha! Welcome, Big Nate. What do? We can't minus the 2. To minus the 2, this is why we call it a two-step equation. To minus the 2, we know we have to minus the 5 plus the 3. So what we're going to do is we're going to minus the 5 and plus the 3. So my final answer is 13. Thank you for the follow. I'm confused. Don't be confused. What are we doing? We are looking at our numbers. So if I look at this number, right? Once more, please. Okay, we'll do it again. We're looking at these numbers. I want to just circle it, right? So what we're going to do is we're going to add the 8. We add the 8, and we want to add the 5. When we add the 5, what are we going to do? Okay, put it in the chat when we add the 5. Well, how do we add this 5? Do we have enough beads to add the 5? Do we have enough beads to add the 5? Add the 10. No, we don't. You're right, Bella. No, we don't. So how do we add the 5? How do we add the 5 to this? Yes, Ellie. Minus the, so we add the 10. We add the 10. And then what do? We're going to take away the 5. So this is the formula that we're going to use. This is the 10 formula, right? We kind of blew through it, but that's the 10 formula. Plus the 5, yep, minus the 10, remove the 5. That's what we're going to do. I'm going to add the 10, and I minus the 5. So my final answer is 13. We're okay with that, right? So now the next question is this one. The first thing I'm going to do, oh my God, I didn't lock in. Now I'm locked in. It makes sense. Yeah. See, I don't, I'm trying to understand how to make it more understandable, because I know that what I do, like in my head, it makes sense. Because what we do is we focus on the add-in, right? We do not focus on the result. So what happens is I'm going to add the 5. I'm going to add the 5, right? Now what do I want to do? I just got here. I'm trying to understand. Hey, Flores. So let me finish my thought and then we'll do a review. So I'm going to try to add the 5. We added the 5. We added the 5. Now we got to do is we got to add the 8. Can we add the 8? Can we add the 8? For me, I'm focused on the formulas we made. Once we did that, it made all sense. No, exactly. No, so we need to add the 10 minus the 2. That's one of the formulas, right? Right? I feel like a new person with all this knowledge. Yeah. Yeah. So here, this is my pair. I want to add the 8. To add the 8, I want to plus the 10 minus the 2. That's what I'm doing here, right? So I want to add the 10. But now, if you notice, I cannot take away the 2. Uh-oh. What can I do? What can I do to take away the 2? I have no beads to take away the 2. That's where the 5 comes in. Yes, exactly. Because now, what are we doing? Now, this is what we call a two-step. We took this information, the 10, and then we're bringing this in. Because now we're going to minus the 5, and I plus the 3. Now my final answer is 13. And this is why it's called a two-step. The reason why is because I have to substitute this information into here. Thank you for the heart me, Audrey. Right? Now, does that make sense? So what we just did, so finding the difference is what you took. Yes, the difference is the add-ins. It's all about the add-ins. It's not about the results. Focus on the add-ins. The question is always, what can I do and what am I doing? Right? So the question is always, how am I adding 5? How am I adding 5? Right? That's the question. Not how do I make 13? It's how do I add the 5? That's why we're doing that. This is the reason why we do adding and subtracting. It's easy when it's only 2 add-ins, but in Abacus we have more add-ins. You're really selling me on Abacus. So here's a few questions, and the reason why I show you this, because in Abacus we have more than just two add-ins. I think it's like peanuts to just do two add-ins, right? So here is a question here is a question. When we do this number, we have 8. Let's do this one. We have 8. I add my 8. And then what I'm going to do, I'm going to take away the 2, right? I have 6. And then I add the 9. Can I add the 9? How do I add 9 to this? How do I add 9 to that? There seems to be a problem with your live. So how do we add a 9? Yes, thank you. I want to add the 10 and take away the 1. And then I'm going to add the 5. How do I add the 5? Thank you, Ellie. Thank you, Bella. How do I add the 5? Hello, Chiwi. Let me know if you have any questions. How do I add the 5? Yes. Yes. I want to add the 10 and minus the 5. So my final answer is 20. I'm confused at this part. Well, this part is, it's really about learning the pairs of 10s. So as long as you know how to do the pairs of 10s, then you're fine. There's no double, this one specifically, this book specifically is not dealing with two-step. That's the next book. This third book is only just adding and subtracting 10. This is focused only on adding and subtracting adding the 10. The next book is subtracting the 10, which I haven't done yet. And then this one is only adding 5. So what we're doing is we only add the 5. When we look at all of these questions, you're only adding the 5. So what I'm doing in this specific book is I'm only focusing on adding the 5. When we do this, right, it's the maze again. But this time we have to answer the question. So here is my question. If I have 4, I'm going to add 4. I add 4. And then I want to add another 4. How do I add another 4? How do I add another 4? If you don't have enough, you go to the next ball and take away the difference from the previous. Yes. But see, the thing is, the biggest thing is the process. So what's going to happen is, it's a process. So it's actually not the ball. It depends on what it is. That's subtraction. So there's an actual framework. This is addition. And so the question is do you have enough beads? If you do, then you add it. Then the next question is if you don't, can you add the 10? Or sorry, can you add the 5? No, you can't add the 5. Then you go to the 10. But if you can add the 5, then you use the 5 formula. If you cannot add the 5 formula, then you do the 10 formula. So you're absolutely right, Ellie. Thank you for catching that. So this is another framework that I created. I didn't create the framework. I just wrote it out, right? But this is the process that goes into my head. Can I do it? If not, how do I do it, right? This is about critical thinking. When we go through each and every question, each and every number, we need to critically think whether or not we can do it. Hello, peaceful presence. Welcome back. How is your kid doing in math? So does that make sense? So every number needs to be analyzed. Don't just blindly, right? Yeah, don't just blindly. I mean, we got to look at it. So here's another question. So here's like we have a bigger question. Let's do a bigger question. Let's see. 2455 plus 130. That was easy. 2455 plus 130. That's easy. this was easy. Somebody did it. I was like, what? 2,000, what is it? 2,455, right? And then when we do it, we go from left to right. I need to add the 1 here. That's what I'm doing. I'm adding the 1. How do I add the 1? Can I add the 1? Can I add the 1? Let me have a 1. 1. Let me have a 2. 2. How do I add the 1? Yes. Yes. I'm going to add the 1 is equal to plus the 5 minus 4. Yes. No, Dean. I want to add the 1. I'm not adding a 4. I want to add the 1. When I add the 1, it's plus the 5 minus the 4. And then what do I do here? I add the 3. Do I have enough? I sure do. I don't need to do anything. I just need to add the 3. And my final answer is what? 258. 2,585. That was an easy one. That was easy. But see, the thing is if you focus on the columns, yeah, we could do it. We would focus on the columns. It's the columns that we're worried what we're looking at. We're not looking at anything else. All right, don't be like all over the place. Let's do bigger. You know what? Give me some numbers. How about that? Give me some numbers. I don't want to have to think anymore. I'm tired of thinking. Hey, White Rabbit, welcome. So, you give me numbers and I'll show you what I can do. How about that? I'm going to flex here. Okay. How do I okay, yeah. So, we have 5. I'm just spitting random. Yeah, that's fine. 6, 8, 9, 45. Now, depending on how complicated it is, but you know everything, right? You know how to add a 10 minus a 10. You know how to add a 5 minus a 5. It just all depends on how you, I don't know if you guys ever played Tetris, but it all depends on how you Tetris everything. So the first thing we're going to do is we're going to put 5,689, right? And then we're going to add the 4. We add the 4 to this one over here. Can we add the 4? So if I look, I'm going to be right here. Can I add a 4? No, I can't. Can I add a 5? No, I can't. So what do? Plus the 4. No, I cannot use the blue bead because I'm adding 4. So it's 4 plus 5 minus 1. I cannot add the 5. So I need to do the next one. What can I do? Plus the 4 is equal to plus the 10 minus 6. So I'm plus the 10 and minus the 6. Let me minus the 6 first. So I'm going to take away the 6 and I'm going to plus the 1, plus the 10. Because remember, 10 is a 0 and a 1. 0 and a 1. 0, 1. So I'm going to add the 1 here. I'm going to add the 1 right there. 2-step? Nope, not 2-step. This is not 2-step. So now I have, what do I have? 5, right? 7, 2, and then we need to add the 5. This is not 2-step yet because this is just a minus. This is not a 2-step. So now we got to do is plus the 5. To add the 5, is there enough to add the 5? No. What do? How do I add the 5? I'm over here now. How do I add the 5? We know this. Plus the 5 is equal to plus the 10 minus 5. So all I have to do is minus the 5 and then plus the 10. Yes, I'm going to plus the 10. So my final answer is 5, 7, 3, 4. Now do you see how reading the numbers makes sense? This is why I stress reading the numbers, because all I have to do is just move my beads and then I have my answer. Okay, I'm starting to get it. Isolating, yeah, isolating it really helps because this is too much to see. So when you look at it, I only want to focus, you really only need to focus on two columns. Even in mainstream math, you only need to do two columns. Thank you so much for the rose. Short and spinny. Thank you for the follow. So yeah. So what we're doing is we're focusing, and even when we do this in regular math, what do? I think they say, well, this goes into 90. So you do 569, and you got to keep the plus one in your head. And then what? And then you got to like add the 45, and then you know that. But see, this is still memorizing, right? Here, we're still memorizing because we know that 9 plus 4 is 13. Then you carry the 1. So do you see how I carried the 1? That's what I did here as I carried the 1. So using the plus 10 formula is carrying the 1. And then we did a 5. But then don't forget we have this. We had to take it away because I added up to here. I don't know. I don't know how to do new math. I honestly don't know how to do new math. I don't know why that's what they're doing. Subtraction. Okay, let's do subtraction. But see, then the other thing is, if you notice, the other thing is they do, I don't know, they do boxes. Like this is 600. 1, 2, 3, 4, 5, 6. And then 80. 1, 2, 3, 4, 5, 6, 7, 8. And then 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then what happens? You have to do 40 plus 1, 2, 3, 4, and then 5. 1, 2, 3, 4, 5. And then what happens? Then you got to combine it all, and then you got to trade it in. I don't do new math. It's cumbersome. New math. I feel new math is cumbersome. Is it a problem? It's not a problem. It's just a different way of looking at it, right? It's a different way of looking at it, and I think that I get a little upset because this is still a picture. If you notice, this is still a picture. But when but when you compare it to the real thing, this picture still doesn't translate. I don't excuse me. So, I don't understand why we still do pictures. If we really want the kids to understand, I don't understand why they don't use manipulatives. I'm lazy, and seeing it like this really makes it easier than before. Okay, so subtraction. Sorry, yes, I think my coughing spell will subside. Okay, so subtraction. Easy thing to do. La, 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 la. Here we go. Okay, so with subtraction, I really appreciate that you guys understand like the complexities that we're doing here. So let's do a number. And it's not like it's simple. I think it's underrated. Excuse me. Um 87 minus 8. That should be easy, right? Why? Because we know our partners. So if I add 87, right? And then my partner, I want to minus the 8. To minus the 8, can I take away the 8 here? No, I cannot take away the 8. So what do? I have to do something with two columns. What do? Minus the 8. No, exactly. So what do? Minus the 8 is what? equals minus 10 plus 2. So what am I doing? I'm going to minus the 10. So I'm going to take away, remember this is 0 and 1. So I'm going to minus the 1. I'm going to add the 2. And I add my 2. So my final answer is 79. It's finally clicking in. Yeah. Oh, that's fantastic. But see, the thing is, there's no rush. I don't know why we're always rushing the kids to, like, do mental math. And I think, just looking at it just kind of helps, right? We can do another one. Let's do another one. Okay. We do, 91 minus 5. What is the formula for 5? So we have 90, and we have 1. What do we do? How do we do this? That's so easy. Yeah. Minus the 5 is equal to minus the 10 plus the 5. Minus the 10 plus the 5. Exactly. Yes. See? It's all because, yes, you're absolutely right. Because we now know their pairs. As long as you know your pairs, you can do anything. Are we ready for a two-step? Yeah? Okay. This will be easy. This will be easy because you're going to see a pattern. We'll do minus. We do 1, 2, 3, 4 minus, well, I don't know, excuse me, 5. We'll do minus 5 because minus 5 is easy. 1, 2, 3, 4. 1, 2, 3, 4, and then take away the 1, right? I'm sorry, 1. So we're at 10,000. 10,000, right? Minus the 5. We take away the 5, right? We know how to take away the 5. What? Yes. This is what we're doing. We're going to take away the 5. Can we take away the 5? We're ready. We're ready. Can we take away the 5? Minus the 5 is equal to what? No, you cannot take away the 5. Yes, exactly. So what are we going to do? Let's change it up a little bit. Let's do plus the 5 minus the 10. Does that make sense? We did exactly the same, but we're reversing the formula. This is called commutative property, right? Commutative property. So what we're going to do is we're going to add the 5. And then what? We're going to take away the 10. Take away 1, take away 0. Take away 1, take away 0. Can I take away the 1? Can I minus the 5? No. Thank you, Dean. Can I minus 5? No. I can't minus 5. So how else can I take away the 1? We know this. Something like this. How do we take away the 1? I'm very lost again. We're only taking away the 1. Hold on. Hold on, Bella. Adding the first subtracting is easier for me to understand. Yes. Now what do? We're here. We're taking away the 10. So we took away the 5, we added the 5, and then we're going to minus the 10. Hey, Babel, welcome back. So what are we doing? 1 and 0. So if we look, what we're trying to do is we're trying to add the 1. We're trying to take away. So minus the 1 is equal to minus the 10 plus the 9. Or we can say plus the 9 minus the 10 equals to plus the 9 minus the 10. That's what we're trying to do. Because we need to take away the 1. We're trying to take away the 1, right? Minus the 10 plus the 9. Because we're trying to take away the 9. Try to take away the 10. So we're going to add the 9. And then what? We need to minus the 10. Minus 1, minus 0. Minus 1. Can I take away the 1? Hey, Jose, welcome back. Can I take away the 1? No. What do? Add the 9. Take away the 10. Take away 1. Take away 0. Can I do it? No, I can't. So what do? Add the 9. Take away the 10. Can I do it? Can I take away the 10? Yes, I can. Exactly. So I take away the 10. So my final answer is 9,995. What's happening? Oh, nothing much. We're doing subtraction. Subtraction, we're showing how like the number patterns are. Yeah, right? Okay, Bella, let's do it the other way, because adding is easier. So my answer is Jose. Okay, hold on. 9995. Okay, let's try this one. 47 plus. Adding is so much easier. Adding is easier because we think in addition. We don't think in subtraction. Okay, so we do 47. Let's do 47. And then what do? We take away the 1. We take away the 3. How do we take away the 3? Minus 3 equals how do we take away the 3? It's the other way, Jose. It's minus the 5 plus the 2. How do I know? Okay, how do I know I want to take away the 5? Because this is the takeaway. Yeah, right? Because my 5 is bigger, I'm going to be a minus. That's how I do it. That's how I remember it. So when I look at it, I go minus the 5 and then plus the 2. Because I want to take away the 3. That's how I know it. So if I want to add the 3, I'm going to plus the 5. Do you see how they're the same? Yeah. But not the same. But do you see how they're similar? You add and you add. Because there's... Thank you. Oh, Dean. Okay, yeah. Have a good night, Dean. Have a good night. And I'll see you in my next live. Okay, so it's 1. Oh yeah, 1 in the morning. Yeah, it's getting up there for me too. Okay, so if subtraction is easier for you, let's go back to this number. So I have 1,000 and I need to take away the 5. Do you understand how to take away the 5? And so now what this is this is now what we consider like a 2-step or a multi-step, right? So we take away the 5, right? How do we take away the 5? We want to add the 5 plus minus the 10. Add the 5 minus the 10. I'm going to add the 5, right? To add the 5, where am I? I want to do this. Okay. So if you look, I want to add the 5. I added my 5. And if you notice, the columns are lined up. So I'm going to add my 5, right? My columns are lined up. I'm adding my 5. Okay, hold on, Jose. So I'm going to add my 5, right? And then what am I going to do? Do you see how there's a 10 here? The 0 and the 1 is a placeholder. The 0 is a placeholder. So when I do 10, I'm going to go here. Does that make sense, Bella? Hey, Ish. Welcome back. Yes. So when I want to minus the 1 here, right? When I want to minus the 1, what do? How do I take away the 1? How do I take away the 1, Bella? Thank you for liking the live. I'm drawing a blank. To take away the 1, can we take away the 5? No, because there's no 5 to take away. So the next one we have to do is the how to make a 10. So minus the 1 is what? Minus the 10 plus the 9. Minus the 10 plus the 9. So we're going to add the 9, and then look, I want to take away the 10. Minus the 1, minus the 0. Minus 1, minus 0. Can I take away the 1? No. So I got to do it again. Minus the 10 plus the 9. So I'm going to plus the 9, and I'm going to take away the 10. Take away the 1, take away the 0. Take away 1, take away 0. Can I take away 1? No. What do? I minus the 10 plus the 9. So I add the 9 and I take away the 1. Can I take away the 1? Because remember, it's 1 and a 0. Can I take away the 1? Yes. So I'm going to take away the 1, and my final answer is 9,995. So what I was showing is a number pattern. So we have our next question, which is 1250 minus 1. Same thing, right? So we're going to do 1,250, take away 1. Take away 1. How do we take away the 1? Can we take away the 5? No, we cannot take away the 5. What are we doing? Well, if we can't take away the 5, if we can't take away the 1 and we can't take away the 5, what's the next one? Minus the 1 is equal to plus the 9 minus the 10. So I'm going to minus the 9, I'm going to add the 9, and I need to take away the 10. Again, take away the 10. Take away 1, take away 0, take away 1. Take away 0, take away 1. Oh my gosh, Bella, go to sleep. That's why you can't get it. It's like 3 in the morning for you. Have a good night. So when we want to take away the 10, what do? Minus the 1 equals to minus the 5 plus the 4. Minus the 5 plus the 4. So my final answer is 1,249. That's why, Bella. It's like really late. I can't believe you guys are doing midnight math. That's like crazy. That's like beyond crazy. All right. So, I don't know who else is here. Have a good night, Bella. I'll see you in my next live. Who else is here? Anybody else? Midnight Mather. Jose. Oh, if it's just you and I, do you want to go to multiplication division? Oh, hey, Ellie. Oh, okay. Cool. You understand did you understand this part here when we did subtraction? This is actually a two-step equation as well. Yep. But if there's nobody, if it's just the two of us, I'm up for some multiplication division. Multiplying is scary. No, it's not. Actually, it's really quite easy. It's really quite easy. I will show you. Let me show you the way. So let's do something easy. 23 times that by, I don't know, 7. Let's do that. You just keep taking from the next one over. Yes, exactly. Exactly. And that's the thing. It's like, okay, we could do that one too. 23 times that by 5. So the first thing we're going to do is we're going to understand what are we going to do. We need to find our starting point. But yeah, Ellie, exactly what it is. Because you have the information. Now you just got to figure out how to Tetris your way through, how to build it. And that's what it is. So the first thing we're going to do is count it. 1, 2, 3. 1, 2, 3. So we are going to start somewhere around here. This is what we're going to do. Why? Why? Because we kind of know it's around here somewhere. Whether it's more or less, we don't know. And then we do, in Abacus, we go left to right. So we go 7 times 2 equals to 14. I add my 1, and then I add 4. And then 7 times 3 is equal to 21. I add my 2. There's not enough beads to add the 2. So what do? Plus the 5 minus the 3, and I add the 1. Yes, that's exactly what it is, Jose. That's it. That is multiplication. Easy. So let's do this one. Same thing. 1, 2, 3. 1, 2, 3. We do it again. Okay, I remember. See, I told you it's easy. 1, 2, 3. 1, 2, 3. 2 times 5 is 10. 1 and 0. 3 times 5 is 15. 1 and 5. That was too easy. Too easy. Yeah. Multiplication's easy. It's the division that's a little bit. Because sometimes if you have the way we do division in Abacus, it gets a little unruly. That's it? That's it. Let's do a bigger number. Let's see if I can do a bigger number without messing up. That means I need a bigger abacus. Okay, let's do a bigger number. Okay, 1, 2, 3, 4, 5. Okay, we have enough. Do we have enough? Yeah, we have enough. 1, 2, 3, 4, 5. Let's do that one. Okay, so 1, 3, 5, 2 times that by 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right. Hopefully I can make that. Good. Okay, so 6 times 1 is 6. 6 is a single digit. I go back one column, I add the 6. 6 times 3. 6 times 3 is 18. I add 1. I add 8. 6 times 5 is 30. I add 3. I add 0. I add 3. Can I add 3? No. I can't add 3. What do? Plus the 3 is equal to... Here, I know I cannot add the 5. So plus the 3 is plus the 10 minus the 7. Plus the 10 minus the 7. That's a 3. And then 0, right? Because that's the 0. And then 6 times 2 is equal to 12. Add the 1, add the 2. My final answer is... what? 8, 1, 1, 2. I got lost. Okay, let's do it again. Let's go slower. I know why. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right? 6 times 1, we got that. 6 times 1 is 6. We're okay with that? 6 is a single digit. I go back one column, I add the 6. The reason why is because I pretend that there's a leading 0, so it looks like that. 0, 6. Does that make sense? So 0, 6. I add the 6 here. Now what? 3 times is 18. When I add 18, I add 1, I add 8. I add 1, and then I add 8. So then the next one is 6 times 5 is 30. This is where it gets a little hairy. Why? Because this is my question. I need to add 30. I need to add 3 to this column. I need to add 3 here. How do I add 3? How do I add 3? Yes, plus the 10 minus the 7. Minus the 7 plus the 10. So I'm going to add the 10. That's it. 3, and then this is 0. My finger stays here. And then 6 times 2 is 12. Add the 1, add the 2. Oh, good. I got the same answer. See, but that's the thing. You can't just because we're doing multiplication, you cannot just throw away your addition and your subtraction information. That still needs to be with you. Yeah, you just got to take it slow. Yep. Yep, 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 yep. Ellie, are you okay? Did that make sense? Okay, good. See, easy. Easy, right? Because the reason why is because the abacus tracks your numbers. You don't have to for the, yes, 0 for the placeholder. And that's what was the big thing. The biggest thing that I think was an epiphany for me to explain it to you guys was that having a 10 is a placeholder. The 0 is a placeholder. When we do 10, right? When we do 3 equals to plus the 10 minus the 1, 10 is 0 is the placeholder. Is where you pick next, right, left. It will always be the left, no matter what. It will never be the right. I know the formula of 10 minus x. Doing it into practice is the part I need to work on. Yeah, yeah. You know what, Ellie? It's the right. It's not right. It's the left. It's always going to be the 10 because we never minus this way. We never look at this. We never say, oh, we need to take away the 10. We never go this way. We always go to the left. It's always going to be the left, not to the right. Does that make sense? Because this doesn't make sense to me because it would be negative. And it would be the tenths. It would be in the decimals. I don't know. That would be just odd. But yeah, stacking is, from the stacking it's greater. Oh yeah. So when we look and when we do this, we always go from left to right. So when we take away, like it's like carrying one and borrowing. We always carry the one or we borrow from the left digit, which happens to be position agnostic. We can do negatives, but it doesn't make sense, if that makes sense. So we could do just like 31 times that by 3. It's the same thing. 1, 2, 3. 1, 2, 3, right? 3 times 3 is 9. 9's a single digit. I add 1. 3 times 1 is 3. 3 is a single digit. I add 3. Yeah. Is that even a question? I don't... No judgment. No judgment. But yeah, I mean, we can go more, right? So let's say we did, I don't know, 4, 3, 5, 7 times that by 4, 9, 5, 3, 2, 2. We'll do 2. We could do that. But that means I got to get a bigger abacus. Oh, here it is. So what are we going to do? We're going to count it. We're just midnight mathing. We're just midnight mathing. We're counting 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right, so we're here. This is gonna get hairy. This will be my last one. Hopefully I go out as a bang. Hopefully it's correct. That's the first thing. 4 times 4 is 16. I add my 1, I add my 6. Okay, mine too. All right, hopefully we're okay. 4 times 3 is 12. I add my 1, I add my 2. 4 times 5 is 20. right? 4 times 5 is 20. I add 2, I add 0. 4 times 7 is 28. Equals 28. Add 2, add 8. All right. So we're done with this. Now we're going to do. We got to recount. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we're here. 9 times 4. 9 times 4 is 36. Add 3. Add 3. Cannot add 3. Plus the 10 minus the 7. Add the 6. Not enough. Plus the 10 minus the 4. We're here. 9 times 3 is 27. Add the 2, add the 7. Add the 2, add the 7. 9 times 5 is 45. Add 4, add 5. Add 4 plus the 10 minus the 6. Add 5 plus the 10 minus the 5. 7 times 9 is 63. Add 6, add 3. Okay, we're done with that. Ellie, don't say that. What if it falls? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 2 times 4 is 8. 8 is a single digit. I go back one column, I add 8. Cannot add 8. Plus the 10 minus the 2. 2 times 3 is 6. 6 is a single digit. I go back one column and I add 6. Plus the 10 minus the 4. 2 times 5 is 10. I add the 1 and I have 0. 2 times 4 is 14. Plus 1 plus 4. My final answer is 21, 4. That's a 4. 3, comma 6, 4, 4. So 1,143,644. I have no idea what the correct answer is, but yes, that's correct. Really? I have to check it out. 4, 3, 5, 7 times 4, 9, 2. 2,143,644. Yeah, great. Okay, I'm done. Yeah, I was just saying, my brother, he would, because we're both Abacus teachers and we have a brick and mortar, and so if the kids do not hold their abacus, he'll come in and do this, and and everything gets messed up. And I'm like, why do you do that? He goes, they need to hold their abacus. That's what they need to do. And I'm like, that's so mean. So I understand. That's right? Sometimes the kids would cry, oh my God, I gotta do it again. Oh my God, it was so bad. Anyways, he's a tough lover. He's the type that does tough love. Tough love. So, right. That was just about it. I'm getting kind of tired, and I'm happy that everybody makes sense. Like, it made sense, right? It's pretty good. Thank you, Jose, for joining me. It's been a little bit. I had so much fun. Thank you for teaching me. I'm looking forward for our next live. Yes, thank you. It was fun midnight mathing. Yeah, right, Jose? Oh, yeah. It's been a little bit. It's been a while since I've actually done some midnight math because I think I've just been falling asleep. You know, have a good night, Ellie. I figured out the whole large large quotient, and I think I'm going to do a post on that because it was one of those things that I was trying to figure out, like, why do we do it? But anyways, but yeah, I'm gonna head to bed. Hopefully you're okay. Everything is okay. Everything's good with you. Yeah. This Saturday I'm called Los Globos. Huh. I don't know where that is, and I'm kind of old. I didn't know you were a DJ. What kind of music do you DJ? And are you going to go live? Oh, that'd be awesome. Go live. Go live while you DJ. That's kind of cool. I do follow a few DJs. In April. Oh, and in February. Huh. I found out about you after playing the Los Lobos in March, in April, and February. You found me? Oh, interesting. After playing at the Los Globos. Interesting. I meant to say February. Oh, okay. Why? Because it was midnight math? Is that why? Yeah. Oh. Yeah. Yeah. You know, I actually that's when I started to go really heavy on lives and stuff, and so, but I think I'm trying to figure out like a better schedule. Everybody keeps telling me. I was at my girlfriend's house. Yeah. Yeah, everybody keeps telling me that I need to have a schedule. But I kind of like it everywhere after my gig. Oh, but that means you're like pretty hyped up if you're like doing math after hours. That's crazy. That's really crazy. I'm a weirdo. I love learning. I appreciate that. I appreciate that. Huh. Yeah. I enjoy teaching. I really and I think I enjoy teaching adults because I can have jokes. You know, kids kind of they don't really know the jokes. My jokes. So, yeah. Alrighty. I am going to head out. Thank you again for joining me. Peaceful Presence. I don't know if you're still here. And Blue Raptor. I don't know who else is still here, but I do appreciate everybody joining, and I hope everything was okay. Thank you again, Jose, and I'll see you in my next live. I love you too. I love the support. I do appreciate all the support you guys provide. Let's midnight math again. Okay. Okay. I will continue my midnight math then. Okay. All right. Have a good night.